I now want to take a look at several different types of variation. Now the first type that I want to look at is a type called direct variation. Now direct variation can sometimes be called linear variation, so I'll make a note of that here. And the reason that it can be called linear variation is because if you say y varies directly with x, you can write that y equals some constant k times x, which of course is a linear equation. But it's not just any linear equation. Direct variation means linear, but with a y-intercept of 0. In other words, the graph of direct variation relationships has to pass through the origin. So, for example, circumference of a circle varies directly with its radius because circumference equals 2 pi r. In this case, the constant of variation is the 2 pi, and here you see the r, which is your representative x value, and you see your output being the circumference c, which is representing y here. And notice that in this formula there is no plus or minus anything on the end. There is no other constant being added or subtracted or whatever. So that is an example of a direct variation type relationship. Now there's lots of other examples, but remember, again, for direct variation there can be no constant being added. Now, if you have a data set in front of you and you're wondering, how do I know? Does this data represent direct variation or not? Well, if we take this formula, y equal k times x, and we divide both sides by x, we get that k equals y over x. So that means in a direct variation type relationship, the output divided by the input, the y divided by the x, always has to give you a constant result. In other words, if I had the input-output pairs 1, 3, 2, 6, 3, 9, and you're wondering, can I model this with direct variation? We could take 3 divided by 1 and we'd get 3. 6 divided by 2 would give us 3, and 9 divided by 3 would give us 3. So this is a direct variation relationship because I can divide output by input and get the same constant every time. Now the next type of variation that I want to look at, we've looked at direct, I want to look at inverse. Now direct variation means output equals a constant times the input. Inverse variation means output equals a constant divided by the input. So direct variation versus inverse, multiplication versus division. Now we can solve for k again. I can multiply. Let me rewrite this. Multiply both sides by x. They cancel. And I get that k equals x times y. So this is the way you spot an inverse variation, in that they have a consistent product instead of a consistent quotient. So if I had input-output pairs like 2, 1/2, 3, 1/3, 4, 1/4. When I multiply these together, 2 times 1/2 gives you 1. 3 times 1/3 gives you 1. 4 times 1/4 gives you 1. You're going to see a consistent product here instead of a consistent quotient, and that's how you know that you have inverse variation on your hand if you have ordered pairs and you're being asked to tell the difference between the two. Now, of course, there are other types of variation that go with this, and I want to go ahead and look at. The next type is called quadratic. Quadratic variation is more like direct variation than inverse, in that you've got y equaling k times an x squared instead of a plain x. On this one, they typically won't ask you to be able to distinguish it from the others. The first two are really the two that you have to be able to tell apart. So we've got quadratic. You can also have joint variation. Joint variation means that y is equal to k times an x times maybe a z. In other words, y equals k times two inputs instead of k times one input. So we have our quadratic, we have our joint, we also have an inverse square. And again, the word inverse implying divide instead of multiply, which is y equal to k over x squared instead of k times x squared. So that's 5 different types so far. We had our joint, we have our inverse, we have our inverse square. We can tell the difference between our direct, we can tell the difference between our inverse and our direct. Now, what types of problems are we going to be asked to work with these, though, is going to be the question. What type of things do we need to be able to do? Well, in any one of these, they'll tell you first which type of variation you're dealing with. And then you pick the appropriate formula. Once you've picked the correct formula, they will give you enough information to be able to find the k for that particular situation. Once the k is found, you put it back into the formula, and then, once it's in the formula, they'll give you another x or another x and z, and ask you to take that and find a new output. Alright? So, let's say, for example, that they tell you that tuition costs varies directly with number of credit hours taken. So you hear the word direct and you know this is the one we're going to use. So tuition equals some constant times credit hours. So we know what the formula is. And then they go on to tell you, well, tuition was $10,000, so T was equal to $10,000 when you had 10 credits. So plugging in, we'd have $10,000 equaling some constant times 10 credits. So now, dividing by 10, we can solve for k, and that would be a constant of proportionality of 1,000. Now once you have k, you put it back into your formula. And then they ask the actual question that they want an answer to. If 10 credits cost $10,000, what would 15 credits cost? Now you have enough information to plug that in, and you can easily answer the question. So you find first which type of variation you're working with. You plug everything you can into the formula, because you've got to find k first. Once k has been found, you plug the k back in, you plug in the given numbers, and you can solve the equation.